Imagine watching a surgery unfold on a screen. Do you ever wonder how a computer could understand what's happening? That's the magic of surgical scene graphs. These are like visual maps that capture everything in an operating room: tools, organs, and how they all interact. But here's the catch: traditional methods miss some key details. Think of it like trying to read a map without knowing which hand is holding the compass or what action the surgeon is taking. Today, we're diving into a groundbreaking study that's changing the game. Researchers have created a new dataset called Endoscapes-SG201 and a method called SSG-Com to make these surgical maps way more precise. Let's break it down. First, why does this matter? In surgery, every action counts. A tool might be cutting, grasping, or coagulating. Those are action triplets that need to be tracked. Plus, knowing which hand is doing the work, like the surgeon's right hand versus the assistant's, adds critical context. Previous models ignored these details, but this team says, no way, we need to include them. So how did they do it? They took an existing dataset, Endoscapes-SG201, and upgraded it. They refined the labels, split the generic tool category into 6 specific ones, like clippers, scissors, and bipolar forceps, and added annotations for actions and hand identities. It's like giving the map a magnifying glass to spot every tiny detail. Their method, SSG-Com, goes beyond just showing what's there. It builds a graph. Think of it as a network of connections, where each tool, action, and hand is linked. For example, if a surgeon's right hand is using a grasper to lift a gallbladder, the graph captures all those relationships. This makes the system smarter, helping it understand not just what is happening, but why and how. The results? When tested on tasks like assessing the critical view of safety or recognizing action triplets, their model outperformed previous methods. It's like teaching a computer to read the entire surgical story, not just individual sentences. This isn't just about better data, it's about safer surgeries. By improving how computers understand operating rooms, doctors can get real-time insights, reduce errors, and even train future surgeons more effectively. So next time you see a robot assisting in surgery, remember, it's powered by these tiny, intricate maps. And thanks to projects like this, the future of surgery is getting a whole lot clearer. Imagine you're watching a surgical video, and you want a computer to understand exactly what's happening. Not just the tools or the anatomy, but how they interact, like a grasper grasping a duct or a hook dissecting tissue. That's the goal of this research, which uses a special kind of map called a surgical scene graph to capture these complex interactions. So how does it work? Think of the graph as a network where nodes are surgical tools, anatomical structures, and even the hands operating them. Edges, those lines connecting the nodes, show relationships. For example, if a tool is grasping an organ, that's one type of edge. If it's dissecting tissue, that's another. The key innovation here is that the model doesn't just track where things are, spatial relationships, but what actions are happening. To do this, the researchers trained the model to classify these edges. For each connection between a tool and anatomy, the system predicts the action type, like grasp, dissect, or retract, using a classifier. They also added a layer to identify which hand is using the tool, left, right, or an assistant's hand. This extra detail helps the model understand context, like whether a surgeon is using their dominant hand or if an assistant is helping. The magic happens in the training process. The model learns by comparing its predictions to real data, using a loss function that measures how wrong it is. This loss combines 3 parts, one for detecting objects, one for figuring out meaningful connections, and another for classifying actions. By balancing these, the model gets better at recognizing the nuanced steps of surgery. When tested, this approach outperformed existing methods. In tasks like predicting critical surgical steps, CVS, or identifying tool-action pairs, triplet recognition, the model achieved higher accuracy. For example, it scored a 24.2 MAP, a measure of accuracy in triplet recognition, surpassing other models by a significant margin. What does this mean? It means computers can now see surgery with more depth, helping train surgeons, improve robotic systems, or even assist in real-time decision-making. The researchers also created a new dataset, Endoscapes-SG201, to push this field forward. So next time you hear about AI in healthcare, remember, it's not just about recognizing shapes. It's about understanding the story behind every surgical move. Thanks for watching. Hit subscribe for more deep dives into science and tech. Ever wonder how AI is helping surgeons during complex operations? Let's dive into some cutting-edge research that's transforming how we analyze surgical videos. Imagine a world where machines can understand the chaos of an operating room. That's exactly what these studies aim to do. Researchers are developing tools to automatically segment surgical scenes, detect objects like instruments and organs, and even assess whether a surgeon has a critical view of safety, like making sure they're not accidentally harming a vital structure. The key breakthrough? A massive dataset called Endoscapes, created by teams like Murali and colleagues. Think of it as a library of labeled surgical videos, where every tool, organ, and action is tagged. This dataset lets AI learn the language of surgery, just like how you learn to recognize cats in photos. But how do you teach a computer to see during surgery? One approach is turning videos into spatiotemporal graphs, like mapping the operating room as a network of connections. Tools, tissues, and even the surgeon's movements become nodes in a graph, helping AI track relationships in real time. It's like giving the machine a roadmap of the surgery, so it can predict what's coming next. Another game changer. Attention mechanisms. These are AI techniques that let computers focus on the most important parts of a video, much like how you zero in on a specific detail in a busy scene. For example, a system might highlight when a surgeon is suturing a blood vessel, ensuring they're doing it correctly. What's the big deal? These tools could one day assist surgeons in real time, flagging risks or suggesting steps during procedures. They also help train future surgeons by analyzing thousands of operations to identify best practices. So next time you hear about AI in healthcare, remember, it's not just about robots taking over. It's about empowering humans with smarter, safer tools. And this research is paving the way for a future where surgery is more precise, predictable, and life-saving than ever before.